in 1D. So we've got three different graphs we're going to take a look at. Position versus time, which we can get the most information from. Velocity versus time, and then acceleration versus time. Here's a simple position versus time graph. And just as a reminder, positive positions means you're in front of the reference point, and negative positions means you're behind the reference point. For this graph, we've got these positions in front and these positions behind. So that means if you're at the 0 position or you're crossing the x-axis, you're at the reference point. What else can we learn from our position versus time graph? Well, anytime you have one of these horizontal sections, that means you're standing still. The other way we could phrase this is you've got a constant position, or your velocity is 0. You're not moving. If we're moving forward, we're going to have a positive slope, and that's a positive velocity when we're moving forward. Negative slopes mean negative velocities. In other words, we're moving backwards. Now, if you've got a curved line for your position versus time graph, we can still understand all these same things. In particular, any time that we've got a slope upwards, even if it's a curving slope, we're moving forward. And we see that for all three of these segments here. Slope downwards means you're moving backwards. Now, when we got these kind of curves, we don't necessarily stand still, but these places where it flattens out is where we've gone from moving forward to moving backwards. So you change direction. And that's going to happen anytime you've got one of these inflection points in the curve. Now, we can also learn a little bit about our acceleration. When we've got a positive acceleration, that's going to look like a place on the graph where the curve faces upward. And we've got one of those right here. We've got another one right here. Negative acceleration is going to be when the curve faces downwards, like we've gotten these two sections over here. And if you've got any sections where the curve is flat for that section, it might transition into a curved one. But while the line is fairly flat, that means we've got no acceleration in those particular areas. So just to summarize again, positive and negative positions tells you where you are relative to your reference point. Constant positions, or where you're standing still, is your horizontal section. Constant velocity in general is straight slopes, with an upward slope being positive velocities and a downward slope being negative velocities. And if there's a curved segment, that means you've got acceleration, with curves facing upwards being positive and curves facing downwards being negative. Well, now let's look at the velocity versus time graph. Again, I'm going to start off with one of these sort of straight line segment type things. In these cases, positive means that we're moving forward, negative means we're moving backwards. And again, we can represent those on this particular graph as these two different sections. Our not moving is where we're crossing our x-axis. And in this graph, it does it twice, once at the beginning and then once around 7 seconds. The other things we can learn from our velocity versus time graph is what's happening during these particular segments. Now, in these flat segments, it's not constant position anymore. Now it's constant velocity. And that means I've got no acceleration during those time periods. If I've got a positive acceleration, that's a section where I've got a line sloping upwards. Here's another section where I've got an upwards positive acceleration. Each one of these are straight line segments, so that means the acceleration is constant on each segment, but it's a little bit higher slope over here, so that's a little bit larger positive acceleration. Anytime you've got a downward sloping segment, that's going to be a negative acceleration. And again, since this is a straight line, it's a constant negative acceleration over that entire segment. Now, the other things that we can look at on this type of a graph is whether we're moving further away from the axis or closer to the axis. Whenever you're moving further away from the axis, that means you're speeding up. Whenever you're moving closer to the axis, that means you're going to be slowing down. So what about this segment over here? Well, you're moving further away from the axis. So that means this particular one is speeding up. You're just speeding up in the negative direction. Remember, speed doesn't care about your direction. It only cares whether you're going faster or slower. And here you're going faster backwards. So again, positive and negative depends on which direction you're going. Horizontal sections are constant velocity or zero acceleration. If you've got straight slopes, they're constant accelerations, with slopes upwards being positive, slopes downward being negative. And speeding up or slowing down is represented by your distance from the x-axis. Now we've got acceleration versus time. And in this course, we're only going to deal with some really simple examples. For no acceleration, your lane stays on the x-axis. For constant acceleration, you get a horizontal line either above the axis for positive or below the axis for negative. And you can kind of picture this, so I don't even have to plot it. The other thing that you're going to be looking at, and you'll have to practice this some more, is where you've got three different graphs, x versus t, v versus t, and a versus t. And you want to have the graphs all have the same motion properties. Here's an example of this. Here's our acceleration graph over here, and we've got a positive constant acceleration. So our velocity graph also shows a positive, because it's sloped upwards, constant acceleration because it's a straight line. On our position graph, again, we're always sloping upwards, so those are positive velocities. And in this particular case, that velocity is getting steeper and steeper, or our curve faces upwards for